So now what we have is we're discussing state S2, and in that state, or S1 in this case, the second state, we have 16 different push buttons, and based on which one of these push buttons is being pressed, then the encoder will show on the other side the binary pattern for that number which is chosen, and this will be stored in X, and it will be taken from X into a BCD 7 segment display, and then it will show finally on the 7 segments. If any of these push buttons is pressed, then this is a signal for me to move to the next state, because now I'm done with taking the user input. And if any of them is pressed, this is indicated by this OR gate, then that one which will appear on the mux is going to cause the second input to be passing to the output. And when it will pass to the output, remember this is still activated because I'm in this state. Every other tri-state buffer is deactivated, disconnecting essentially its input state from the rest. Then that state here, which is number 2, would be the next state. It would be stored in this shift register. Again, will appear in current, and now the decoder will know to move into the next state, and so on and so forth. So this is what happens. In fact, the muxes would dictate here what state I stay into if the condition is 0, what state do I go to if the condition is 1. Now these conditions can come, for example, from timers, like check here. For instance, I have the 1 Hertz clock feeding into a counter. The counter is simply counting, and the output of the counter is fed into a comparator. The comparator will check against, for instance, I'd like to wait here for 9 seconds. If I see 9, it means the 9 seconds have passed. This means, or I take this output as the signal that will cause this mux to leave the current state and advance in the FSM into the next state. Now this could be coming from some sensor. I have that sensor feeding, for instance, into a counter. That counter now again is comparing the value against some known value that I, for instance, would like to count against, and if this is greater, then I go to the next state. If not, I remain in that state. This is it basically. I go from one state to the other state and so on. This is a time related state where I have a counter, a comparator, and a mux, because the last state is essentially just a count or a wait on time. And in every state here in the outputs, this is dictated by one of the decoder lines being 1, and I essentially turn on whatever I need to turn on. For instance, if there was a valve, I turn it on at the time. If there was a LED, I turn it on at the time. If there is a motor, I turn it on at the time. If there is a frequency that I need to generate, then I put that frequency there. And after I put that frequency, I just use the frequency once to turn on the motor, the other time to, in an inverted case, to turn on the valve, because their action has to be synchronized. So this is it for the question. Any finite state machine can be turned into something like that. All what you need to do is the F statements that you usually have in the switch for every case are now going to be deciding here the numbers that will appear in the muxes. You have input circuits, and they can either be the time-based, input from the user, or sensor-based.